Okay, so I'm going to do these so that you can refer to them if you need to. The only way you can do this one is to add common denominator. So I'll do the first one first and keep a copy of that elsewhere. So this one. A little bit complicated, but we want to get rid of this. So we're going to multiply both sides by that. But let's find some equivalencies here. Tan squared, just as tan is equal to sine over cos, tan squared is equal to sine squared over cos squared. So that's what tan squared is equal to, which means I can immediately replace this over here with that. And just put a fraction over it. Then you should put brackets around everything. And obviously this is what I want to get rid of. So I want to multiply. You always want to get rid of tans, and you always want to get rid of denominators so that you're working on one line. So that means I have to multiply both sides by this. And you have to follow the rules. And I'm just going to do it like this instead. You have to follow the rules of distribution, which means since these are all being subtracted and added to, I believe they were all subtracted by. So I'm going to just make a copy just so I don't lose track of this and go back and see what's going on. Go back. I believe they're all being subtracted by. It's hard to see, but I believe they're all being subtracted. Yeah, they are. Which means going back, we're at this stage. And if I multiply through here, these cancel. If I multiply here, I get minus cos to the power of 4. If I multiply through here, these cancel, and I'm left with 1. If I multiply here, I'm left with minus cos squared. And if I multiply here, I'm left with minus cos to the 4. So if I distribute here, I'm left with sine squared minus cos to the power of 4. If I distribute on the right side, I'm left with 1 minus cos squared minus cos to the power of 4. If I add cos to the power of 4 to both sides, if I add cos to the power of 4 both sides, so I'll just make a copy. There we go, like that. So I'm going to just add cos to the 4 to both sides. You can see that all the cos to the 4's disappear. And I'm left with sine squared is equal to 1 minus cos squared, which is an identity. But if you can't see the identity, by the way, this is supposed to be sine squared, you can just add cos squared to each side. So I'm going to make a copy. And when I add cos squared to each side, it disappears on the right side. And I'm left with sine squared plus cos squared is equal to 1. And we're done. For this one, oops, I still didn't do it right. Let's try this again. There we go. For this one, I have to cross multiply their denominators. So just don't focus on this right side for a second. And when I cross multiply to get the common denominator, this is how it works, as you know. And then these denominators, and I can put the plus up here in between them. And then these denominators must multiply. So that for this to be over the same fraction, this is where those brackets help. These must multiply, which is what happens to denominators. 1 times 1 is 1. 1 times minus cos is minus cos. Plus cos times 1 is plus cos. And cos plus cos times minus cos is minus cos squared. And it's clear that these cancel out. And I'm left with 1 minus cos squared in the denominator. Well, it turns out that 1 minus cos squared is equal to sine squared. Say that again. 1 minus cos squared is equal to cos squared. That's because sine squared plus cos squared is equal to 1. And I'm allowed to rearrange this any way I want by subtracting cos squared from each side. So that means sine squared is equal to 1 minus cos squared, or cos squared is equal to 1 minus sine squared. So whenever you see that, you can replace them. Since I see 1 minus cos squared here, I can replace it with sine squared. And when I want to get rid of the denominators on the right side or left, I simply multiply sine squared on both sides. And you simply treat it like this. And if I multiply the right side, I have to multiply the left side. Well, it turns out there's a double cancellation. This cancels. And these cancel, and that's because it's sine times this over that, and sine times this over that. So these cancel here. And I'm left with this. 1 minus cos plus 1 plus cos is equal to 2. Well, minus cos plus cos cancel out, and I'm left with 1 plus 1. And it's quite clear that 2 is equal to 2. There you go.